Good evening to everyone.
Good evening, sir.
Good evening, sir.
Good evening.
Excuse me, sir. Sir, your voice is not coming, sir.
Sorry, I am sorry. I was mute. Okay, I will start again. Okay.
पता नहीं सर, कोई बोल ही नहीं रहा था, मेरे को लगा मेरा ही नेटवर्क खराब है, इसीलिए मैंने दोबारा से।
नहीं नहीं, thank you for reminding me. It was mute. I don't know how.
Even same for me also.
Okay. Uh, okay, long range identification and tracking system. So long range identification and tracking system, it is a SOLAS chapter 5 regulation. There is a separate regulation of the carriage requirement, and that is a regulation 19-1. Okay, not 19-1. So this is a separate chapter. Now, what I was highlighting here, that it is not a part of GMDSS equipment. Remember this one, many people think it is a part of the GMDSS equipment because your GMDSS that is given in the separate chapter, chapter 4. Already we have gone through this. Okay, so but it is a chapter 5. So it is not a part of the GMDSS equipment. Second thing, that what I was highlighting here, that although it may use the GMDSS equipment like RMSS, that is the Inmarsat C or Iridium. Okay, so this communication sets, it may be using. It may use or it may have its own antenna. Okay, or communication sets. It may have its own. But if it is integrated with the GMDSS, it may use this one. So it is, although it may use the GMDSS equipment, but it is not a part of the GMDSS equipment. Okay, hope it is clear. Second thing, I was saying here, like this is the para 2.1, where it is saying that all passenger ships, including high-speed craft. So this, which is added, including high-speed craft, it is going to come in near future. And when the SOLAS amendment will take place in 2026, new SOLAS will come. That is consolidated SOLAS, that what we say. Okay, in that it will be included everywhere, wherever like all passengers, including high-speed craft. So you need to remember in this way. Okay, in near future it is going to come in that way. Okay, and this also will be added like all cargo ship, including, now here also it has come, including high-speed craft of 300 GT and upwards. And this was not included before, but it has also included now. These offshore vessels, drilling units, these all are going to be included, okay, in the SOLAS regulation. So this is the new one that has come, but in the SOLAS 2026, when it is going to come, this all will be included in all the chapters. Okay, carriage requirement. Okay, this was the 2.1. And what the regulation says next, that is the para 5. Para 5 is saying about the purpose of the LRIT. Okay, why it should be fitted? What is the purpose of it? So ships shall automatically transmit the following LRIT information. LRIT information. Okay. So what it's supposed to send, what LRIT is sending. LRIT is sending the identity of ship. Identity of ship, already I have told you what is the identity of the ship. Again, I will tell you here. Identity, when we say that includes this information, that is MMSI number. That is the Maritime Mobile Service Identity number, IMO number, name, and call sign. Call sign. This is the identity of the ship. So this will be transmitted. Okay. Next, it is going to transmit the position of the ship. At that particular time, what was the position? Position means lat and long, latitude and longitude. Okay. So, and with this position, the date and time, because without date and time, the position is no meaning. It has no meaning of the position provided. So basically, the ship can be tracked anywhere in the global, wherever the ship is there, it can be tracked. Okay, the position can be tracked. That is the main motto of this one, to send this. Okay. Now, this identity of the ship which we are sending, it is already in the memory of the system. Okay, I will tell you this all again. I will tell you. Let's first see uh, where to send and how we are sending, or to whom we are sending these all things. Okay. And regulation also says that the report LRIT information shall be transmitted every after 6 hours. Okay, to the LRIT data center. Data center, that is which is providing the service. Like if it is the Inmarsat C, Inmarsat C, so Inmarsat C data center it will go. If it is the Iridium, it will go to the Iridium. If it is the COSPAS SARSAT, COSPAS SARSAT, it will go to this. Okay. So these all are having also their own LRIT data center. So it is transmitted to them. Okay. Now, every after 6 hours, so it has become, if every after 6 hours, if you see, then it will be basically 4 times in a day, means per day, 24 hours day, 4 times it will be sent. Okay. To whom we are sending this data? So LRIT users, or who is going to use this information? So information will be used by the, or we can say LRIT users. LRIT users. So LRIT users are flag state. Flag state is entitled to receive the information. LRIT info. So 100% it will be going to the flag state. Okay, around the world, wherever the ship is there, flag state should know it. Now there is a coastal states. Coastal states, they can request this from the data center, request information. Now, request information, if the ship is doing voyage to 1000 nautical mile from their coast. Okay, irrespective of their flag, so they can request this information. So if they are requesting, this has to be also sent to the coastal state. Okay. Then port state. Port state also request the information if if that port is a destination port. If it is a destination port, it may request, irrespective of their flag or location, wherever they are. Okay, so port state is also getting updated where the ship is and when it is going to come. Search and rescue authority. The sole purpose of this one, this also may request information in case of the distress. In case of distress in that particular region, for search and rescue coordinating team. Coordinating team formation. So the ship, if it is the nearby or in the vicinity of that region, they will be a part of the search and rescue coordinating team. So in that particular time, the SAR authority also will request the information. Okay, so these all are the users. Now equipment wise, what all equipment we have? Okay. This message is like from the Lyric data center. So how the Lyric data center that gets, let me tell you, there is something is known as a communication service provider, that is known as a CSP. CSP is communication service provider. So communication service provider, that is not this one. 1 minute. Let me do little change here. They are not the LRIT data center. They are the service provider. So I will delete this one. You can take a screenshot again. Here, this one. Now I'm writing here. So communication service provider are that is not coming. Okay. That is same what I have written. That is Inmarsat. Inmarsat P or Iridium or whoever is there, like Postpass or that also, or Iridium. Okay, they are the service provider. They will send this data because LRIT is going to communicate like this is a shape. So from here, it will send the signal to the satellite, and from the satellite, it will go to the service provider. So it will go to the service provider. This is the land earth station, alias. Okay, and this is a ship earth station. So from there, it will go to the satellite, and from there, it will go to the alias. So this is known as a CSP. From the CSP, this data will be sent through the network to the ASP. Okay, ASP. So second word that is coming, that is the ASP. ASP is the application service provider. Now generally CSP and ASP nowadays both are same only. Okay, application service provider. So they have their own communication protocol, and there will be the interface and add information to the LRIT message, and message will be given between the CSP and the LRIT data center. So they are going to forward this one to the LRIT. There is too much noise in background. One minute. Okay, so LRIT data center. So this LRIT data center, it is going to collect and provide the LRIT information to the LRIT users. LRIT users. So this is how the communication takes place. Now, LRIT consists of equipment wise. So this is having the antenna unit. This is the antenna. And this is not only the antenna unit, this is also having the transmitter and receiver. Both are having in this only. Okay, antenna unit plus communication sets, that is the transmitter and receiver. Transmitter and receiver. In this antenna unit, there is a memory. In the memory, SIP's identity is already fitted because it is not going to change. So it is already fitted in this one. Antenna unit is also going to have the GPS receiver. So if it is having the GPS receiver, that will give the position, current position, and time stamp. Time stamp also it will provide. So there is no need to interface with any other navigational devices. It is not required because it is having its own GPS receiver. So only the power supply will be given. Terminal control unit, this is optional. Okay, if it is interfaced with the other equipment like GMDSS equipment and all, then in that case, this is required. Otherwise, it is not required. Only the power supply will be going to this one. It is having the transmitter receiver plus antenna is there. Directly, it is going to send the signal to the satellite. Okay, that is the provider Inmarsat C in this case, because here you can see mini C LRIT terminal. So it will send to the satellite. Okay, and likewise, this information will go to the data center. Now here, if it is a mini C, like GMDSS is also having the Inmarsat C communication sets. In that case, it can be interfaced with that. Like it is only going to take a few seconds only every after 6 hours, few seconds only to transmit the, okay, receiver I have written, that is wrong. No receiver, only transmitter. So it is going to only transmit the information. Okay, so it is only going to transmit the information. That's it. So every after 6 hours for few seconds, it will transmit. Automatically, it will transmit. And it's supposed to transmit automatically. So there is no interfere with any person also, or to remember. Like we need no need to remember when we have to send this. So automatically it will be sent. Like here in this also written, shifts shall automatically transmit the following in LRIT information. So automatic system, automatically it will be transmitted. So it is programmed in that way, automatically it will go. Okay, any doubt in this to anyone? Okay, then next is SSAs. Let's see about this. Tips, security, alert system. SSAS. Now this is same like LRIT. This chapter is different, and it comes under the ISPS. ISPS, I hope everybody know nowadays. So regulation 6. Okay, so carriage requirement is given as per this SSAS. So it says that all passenger ships here also including that will come including high speed craft, second, all other ships including high speed craft of 500 GT and upwards. Then third, mobile offshore drilling unit or mobile drilling unit. They are offshore only, offshore units. So they're supposed to be fitted with the SSAS, Ship Security Alert System. Now, what is the goal of this one? It is one of the safety measures for strengthening ship security and subduing acts of piracy and or terrorism against ship. So this is the main purpose to put this one. Okay. Now what it does. So when we are going to activate SSAs, when activated, it shall initiate and transmit a ship to shore security alert to a competent authority to that region. Okay, so it is divided into the regions, and all the regions are monitoring these security alerts. So in these circumstances, it will go to the competent authority. So competent authority is generally the dedicated, it is given to the military units only. So military units, they are going to come. Okay. And they will, like if any threat is there, they are going to take the action. So we can say this competent authority is also appropriate military or law enforcement forces. Okay, law enforcement forces. So they are going to get this alert and they are going to take the actions accordingly. Now, when it is transmitting the alert, okay, it is a covert signal. It is a covert signal. Covert signal means nobody will come to know about this. No ship will come to know. No ships, nearby ships, or no ships in vicinity will come to know. No alarm. No alarms. No alarm is raised on board ship. So on board ship also nobody will come to know except who is raising the alert. And it is going to send continuously alert. This continuously it will send continue alert until deactivated or reset. Okay, so this is the SSAs. So once it is activated, it will send the security alert. It is a covert signal, so no ship in vicinity will come to know. No other authority also will come to. Not only the ship, but no other authority except the competent authority of that region. And it is a continue alert until deactivated or reset. Okay. Now, in the ISPS code, And in the SOLAS regulation, it is said that it's supposed to have, it provides, or it shall have a minimum of 2 alert activation point. Minimum 2 should be there, one of which must be on the bridge. It must be on the bridge. So it is saying one should be in the bridge. Second one can be anywhere. Anywhere means mostly it is given to the master cabin. And some ships you will find it is given to the chief engineer cabin, or some ships you will find it is given to the chief officer cabin. Okay, so this is the 3 positions generally you will find. There is many reasons why it is not given to the master cabin, because master cabin is having the most threat. So that's why it is given to the other cabins, because chief engineer, chief officer generally have the less threat than the master. So at least they can raise the alert, security alert. So that's why this is the reason they are saying it is given in the chief engineer or chief officer. Okay. Equipment wise, the service provider which is there, in this case also, there is a same service provider like Iridium or in Barsat. C is there.
नहीं रहने तो अंदर ही बैठ रहा हूँ नेट के नेट नेट के अंदर एक्सक्यूज मी सर
Yeah, tell me. Yeah, tell me please.
Sir, do we have any kind of provision that the SSAS is working in order?
SSAs, yes. We do check this one. So testing is done. So we generally intimate that we are testing this. Okay. So we test, we carry out the test. So you'll come to know that it is working on.
Oh, got it, sir. Thank you.
Sorry. Now, it is also same, it is having same, it is going to send the ship's identity. Ship's position and time stamp. So this will be sent to again the our service provider satellites, and through the satellite, same like LRIT information. This will also go, but it will not go to the LRIT data center. It will go to the competent authority of that particular region. Okay. In this case, we have a control unit here. You can see this is the control unit. So formatted message also we can put in this one and it will be released if we have the time. If we do not have time, then generally this is the activation push button. This is the activation button. One supposed to be in the wheelhouse, and second one any cabin. Any cabin. Here, the green one, if you see, this is the test push button. Test push button. This is used for the testing purpose that everything is okay or not. So this is not a security alert. It will send a test. So test format is different. So we can test also the SSAS by this push button. So that is about the SSAs. Again, it is not a part of the, okay, I must write here. It is not a part of the GMDSS equipment. GMDSS equipment, although it can use the GMDSS equipment, like GMDSS equipment are having the RMSS, so it may use. If it is using the GMDSS equipment, it will be like this. So it is interfaced with the GMDSS. You can see here. So with SSAS, AS means system. Okay. So GMDSS equipment, you can see it is using that one. So this is the antenna. This is the common for Inmarsat-C, and it is interfaced with the CAN. CAN LAN, all are given through that it is using. Okay. That's it. Any doubt up to here?
So the power supply for SAS, we have main power supply, emergency, and DC power supply.
It is same. It is given from the GMDSS equipment power supply.
Okay, sir.
I think there was a question in the group, boiler firing sequence. That candidate is here who has put the question.
Yes, sir.
Are you here?
Yes, sir. I'm.
Okay. Okay. So you want to know about the boiler firing sequence. Okay, I will tell you about that.
Yes, sir. Thank you, sir.
This. Okay. Boiler firing sequence. Okay, I think I'm having trouble here. I need to open a new page. Just I'll open a new page. Boiler firing sequence. See, for the boiler firing sequence, boiler supposed to be, let it be, it always supposed to be in the auto mode. Okay, so there are two modes, you know about that, auto mode and there is a manual mode. So when we talk about the firing sequence, generally we talk about the auto mode of it. So system supposed to be in the auto mode. So in auto mode, it's supposed to be in the standby. Okay, standby. When we are saying standby, means it should not be in the alert or alarm position. Okay, so alarm position means standby means it will come to the standby if your water level is normal, then FO pressure. Okay, I will write here only. This all below things should be in the normal. Okay, like your water level, FO pressure, FO temperature, FD fan. Once it starts, it should be running only. Okay, or no trip. FD fan should not be in the trip. No trip. Okay, and there should not be any ignition or any other alarm should be there, and this all should be in normal condition. Ignition like flame failure, so this alarm should not be there. Okay, so no alarm. Ignition, flame failure or emergency stop should not be pressed. Okay, so these are the prerequisition, the condition. So it will be remain in the standby position. Sorry, standby condition. It will be remain in the standby. Now, when the pressure, okay, we are talking here. Let me first tell you, we are talking about the auxiliary boiler firing sequence. Okay, auxiliary boiler. So this is a on-off control system. Auxiliary boiler is on-off control system. On-off control system means it is being controlled by the steam pressure. So suppose we take one steam pressure, we'll take like 5 bar for starting and stopping is 7 bar. Okay, just for I'm taking this one roughly. Okay, 5 bar it is starting and 7 bar it is stopping. So when the pressure will come to the 5 bar, okay, so it is going to continuously, it is going to check it. So each pressure is less than 5 bar. If it is no, then continuously it is going to be in the standby condition. If it is no, if it is the yes, then in the yes, the pre-purging will start. Okay, your pre-purging will start in this. Pre-purging start. So pre-purging, what will happen in this? In the pre-purging, AFD fan, this starts. A4 pump starts. A4 bypass valve. Now there is a two valves in the FO system. If you see the FO system, which is going to the burner, like suppose this is a pump, FO pump, which is taking a suction. So this FO pump will start and it will go to the nozzle. okay, of the burner. So this is a in the furnace where we have the burner. In the burner itself, you will find there is a two valves are there. One valve that is known as a supply valve, FO supply valve. Here is the solenoid valve. And one is from here, it will be given this is a bypass valve. Bypass valve. Okay, so this bypass valve will go to the mixing column, and through the mixing column, it will generally it can take a suction from here also, and it will be going here. There is a some connection is there with this also like this. Okay, that you need to see how the mixing column is there. Okay, so through the mixing column, then it will go to the here like this. Okay, so this is the bypass valve. This is doing. So generally, these two valves will be there in the burner. Okay, so we are talking about this supply valve and bypass valve. This is the solenoid operated. So here the FO bypass valve. So this will be open, means it is bypassing. Okay. And now it is not going to the nozzle, and FO supply valve. This will remain closed. Your air damper opens fully. The reason for this one, to expel the gases, flammable gases of the furnace. That is the pre-purging. So pre-purging is going to start. It is going to be continue for at least the time, that is the time is there. Some 3 minutes are there. In some systems, it is having the 5 minutes. Okay, so if it is completed, no, it will continue. Time's over. No, yes, then it will go to the next. Okay, in the yes, it will go to the next. Here I must write yes. And this is the no. Okay. Now, if the time is completed, then it will go to the ignition. Ignition. Ignition during this. Okay, now remember, once the FD fan is started, FO fan is FO pump is started, this will too will continue to run. Okay, this will continue to run. This is not going to stop till post purging. After post purging, it is going to be off. So I am not writing again and again this. This once start, it will remain continuously. It is going to run. So I'll just write here, continue to run till post purging. Okay, post purging. At least FD fan will be running. FO fan, it is having again a timing. Okay, after a certain period of time, it will be off. Okay, but FD fan continue to run for the post purging. So this two is going to continue run till the stop command is not coming. Okay, stop command is not coming. If it is stripping for any reason, that time these two are going to off, but FD fan still it is going to run. Generally it runs until unless you are not going to press the emergency stop. Okay. Then ignition. Now two things, FO pump and FD fan, that is running and it will run continuously. I will be not writing that one. Okay. Now air damper. this is going to shut fully. Okay. Then there is a ignition transformer. This ignition transformer, this is going to get the supply. So it will be on. So ignition transformer is going to be on. So spark will generate in electrode, spark electrode. Okay. And last, third one, the DO pump starts and feeding to pilot burner. There is a pilot burner, so it will be going. Now here again, there are two types of auxiliary boiler is there. In some cases, like Aalborg, you might have seen, it is not having the pilot burner and it is having the only main burner. Okay, so main burner. And there is another type which is having only main burner. Okay, so this is the two type. Type 1 you can say here. Type 1 and this is the type 2. Okay. Now, if the pilot burner is there, if it is there, in this, always the DO is going to be supplied. So DO supply is given to the pilot burner. In the incinerator also, pilot burner is there, which is given the DO supply, diesel oil. Okay, and flame will be ignited in the pilot burner. And thereafter it will change to the main burner. In the type 2 condition, where the only main burner is there, okay, in that case, this, your FO supply valve, this will open. It is not going to open fully, but it will open. So there is some other systems are there where the only main burners are there. And the FO bypass valve will shut. This is going to shut. Now, generally, where the only main burners are there, this is having the modulating system. What is the modulating system? You need to understand. Let me again tell you about this one. Just wait. I'll open that picture that will be so you can understand what is happening actually. If you see this, there is a different purging and flush end. This is the of Albor. Okay, but in other systems also it is same. So here it is a flushing period. Now this is the automizing period and this is the stop period. So here if you see this is a preheater. So the oil flow that is going from here, this is the supply valve, this is closed, this is the bypass valve, this is open, and it is just returning back from here. This is the purging tank. Okay. Now flushing, when it has to flush, you can see this is also open, this is also open, and from here, because this nozzle, this piston, it is not pressurized. So if it is not pressurized, there will be no automizing. It will be not going from here. If it is getting pressure like a piston here, you can see this one. Okay. So the oil flow will be going through this and it will be coming from here. Now here something is given. This is a servo motor, fuel oil servo motor, fuel oil servo motor. So this is going to regulate this one. This will be regulated. This is not a solenoid. Solenoid is here, you can see. It is operating, either it is going to be on and off. But this motor, this is a servo motor. So this is going to control the flow of the oil. Automizing when it is there. So during the automizing, this is also going to open. This will be opening. So the piston, this will move out. And here, now the nozzle is going to spray the fuel. And again, this is going to control the fuel flow here. So fuel flow is being controlled. This is closed. Okay. So there are many things in this one. What I wanted to tell you that generally when the only main burner is there, this modulating system means it is going to regulate the air supply, air damper plus fuel. Okay. So the proper burning of the fuel or proper combustions takes place. This is very, very important. Otherwise, there is going to be the pollutant problems will be there. And that's why the proper combustions that is going to take place in the furnace. So it is important to maintain the ratio. So mostly nowadays, you are going to find this kind of things. Okay. And this is given here very nicely. I will put that one also. Little bit I am going in detail so you can understand better. Okay, so you do not have any confusion. What type is there on board your ship? Just go as per that. It is no need to tell in the common, but if you have worked in that system, you will understand better. Now here you see, this is a damper motor, servo motor, and this damper is being controlled here. This is the damper. This is the damper servo motor. This is the fuel oil servo motor, and fuel is being controlled. Okay, so everything is written here. I hope you understood. So this is a modulating system or regulating systems that is known as. So where the main burner is there, this type of things will be there. Now in common to remember what you need to remember, if you are going to explain about the pilot burner and main burner, it is easy to make them understand, surveyor. So if they are going to do any cross question, you can reply. Here it is little bit tricky, but you should know the regulating system, how it works. Okay, so this is important because there is not only one valve is involved in this one or only the bypass valve. Okay, it is one, but supply valve, there are 3 valves are there. Okay, but here I am making it just a common. So if you remember this also, you can tell. So don't go for so detailed. I generally prefer my candidate to go for this one. It is easy to understand and easy to make understand to the surveyor. Okay, pilot burner and main burner. So we'll go as per this. So here, if the pilot burner is there, in that case, your DO pump, this will start and directly it is going to feed to the pilot burner. So your ignition transformer and electrode, they are in the pilot burner. Okay, they are in the pilot burner. Yeah. Now, pilot burner is getting the ignition, pilot burner flame is on. So after the ignition, pilot burner flame. Okay. So it is on. Yes. Then what will happen? Okay. Next we'll go. There will be three lines I will be drawing together. One is the flame eye roll is going to come here. So flame eye, flame is on. Yes, we'll go for the yes here. If it is yes, so flame eye will sense that one. Flame eye is going to sense that. If it is sensing, if it is no, okay, flame eye is not able to sense, that means, okay, we'll not write anything. We'll say flame eye here. Here it is no. In that case, ignition failure will come. So this is the ignition failure. So this is the alarm. Now, if it is yes, if it is going to be yes, in that case, the next sequence is going to start. Okay, next sequence will start. And what is that next sequence? We'll see that one. Okay, if yes, then next sequence will start. We'll see this one. Now here, generally, when the pilot burner is on and pilot burner is going to get off, okay, then what happens? So if the pilot burner flame is on, flame eye that is sensing continuously flame is there. So after 1 and 2 seconds, after 1 and 2 seconds, so just I am writing here only after 1 and 2 seconds, in this A4 valve, this is going to be, this is supply valve, A4 supply valve, this will be on, and bypass valve, this is going to be off. Your flame should be continuing. Okay, remember here. Then after this one, the main burner will have the flame. Both now pilot burner plus main burner, both are going to have the flame. So pilot burner flame, that will be on. Once it is going to establish in the main burner, it will take almost 10 seconds. And after that, pilot burner is going to be off or ignition is off. Ignition mode, that is off. So ignition off means, in this case, pilot burner flame will be off. Ignition off means pilot burner flame will be off. So DO pump stops. Air damper opens. And ignition transformer is off. it is off. It will take from here to here, this point. It will take 10 seconds. Okay, this is also known as a flame establishing time. Flame establishing time. Okay, so this we can say this is the flame establishing time. And once the main burner flame is on, again, this will be also sensed by the flame eye. Now, after this, it will go to the it will be logged in. Logged in period. Once the main burner that is starting, it will go to the logged in. Continue flame will be there. Logged in. Logged in means continue flame is there. And in logged in, two things is going to happen. The high flame and low flame. I hope if you have heard about this one, you will be knowing this high flame and low flame. So it will be again regulated for the high flame. High flame, low flame, if you have the servo motor, it is very easy. And if we have the solenoid, then also it will be same. High flame means the fuel and the air ratio is increased. Okay, it is increased. Generally, this is going to happen during the starting. After the starting, so steam, it is again regulated by the steam pressure. Here, this is regulated by steam pressure. So between 5 bar to 6 bar, there will be high flame. Just I am giving this one to make you understand how it is happening. So it will go to the high flame. After the 6 bar, this will decrease. Fuel and air ratio decrease. When it is going to decrease? After the 6 bar. So it will be continuously firing in the low flame. Okay, it is continue to fire in the low flame. So this will be locked in period. Now here, this one, if there is a no flame, I am making this one AND gate basically. And in this case, there is going to be the flame failure alarm that will come. Okay. So this is the alarm it is going to come. Now this AND gate I have made that after the ignition failure is having a time. It is having a time. It is during the ignition, that is the 10 seconds. So within the 10 seconds, the ignition failure will come. After the 10 seconds, if flame eye is not going to sense the flame, then this will be after 10 seconds. When the main burner is already having the flame, and if the flame is not there due to any reason, okay, in that case, the flame failure alarm will come. Okay, hope it is clear. Okay, next. Now the pressure is steam pressure that is reached to the 7 bar. It is reached to the 7 bar. No, then it is continue to be in this. Okay, if it is yes, then it will go to the post purging. It will go to the post purging. Post purging again here the FD fan. This will be running continuously. A4 pump. This is also going to run continuously because the temperature that has to decrease because your preheater will be on. So that is the reason why we keep this one on. A4 bypass valve. This will be open and A4 supply valve. This is going to close. And air damper will open fully. Fully open. Okay. Thereafter, it will go to the again. It will stop and go to the standby if there is no alarm. So once it is stopped, FD fan stops and A4 pump stops. These A4 pumps will stop before only, not it is going to be like post purging will be for 3 to 5 minutes again. So A4 pump is not going to run for 3 to 5 minutes. Generally A4 pump, because your preheater was on, so preheater will be off and thereafter after 30 seconds or 1 minute, this A4 pump is going to stop automatically. Okay, so this is the firing sequence. Hope you understood. Any doubt? Any doubt now?
सर ये 7 प्रेशर वाला एक बार बताओगे क्या सर? 7 बार प्रेशर वाली साइकिल सर, जस्ट थोड़ा सा ऊपर। हाँ सर, ये वाला।
हाँ, इसमें क्या डाउट है?
सर ये मैंने ध्यान से सुना नहीं सर, नेटवर्क प्रॉब्लम हो गई थी।
अच्छा,
हाँ
7 bar, that is when the steam pressure is going to reach to the 7 bar. Okay, then it will go to the post purging. Otherwise, continuously it will be in the firing.
ओके सर, ओके।
So that's it. Any other doubts are there, you can ask me. Okay, or you just put in the group also. The oral group is different. You can put the message in the oral group. Okay, anything you want to ask me. So just put in that one. You have put in the active group, but I could see that one. There is something. So that's why I put also that are you attending my class? So I wanted to tell you today. Okay, we can have a 5 minutes break, then again we will start. Okay.
कैन यू जस्ट स्क्रॉल डाउन सर? ओके सर, ओके सर, जस्ट लिटिल बट ऊपर सर। बस ओके सर, थैंक यू सर।
Okay, welcome back.
Excuse me, sir.
Yeah, tell me.
Or when we do our DP cell calibration, that time our boiler is in manual mode, na sir?
When you do the DP calibration, you can keep the manual mode or auto mode because actually when you do the calibration, well, let me tell you, let me go there. I think I have taken this class. Yeah. Where was yeah, this was the calibration. So you close this one. This is the box.
Yes, sir.
Okay. So let boiler to fire. There is no problem with this one. Okay. If you put to the manual mode, but you have to watch the water level should not go down. That is the one thing. Okay. Otherwise, if it is in the auto mode, because auto mode is not going to work, you are going to shut here and you are going to do the calibration. Yes, better to keep in the manual mode, but you need to watch the water level.
Okay, sir.
Okay. Need to keep in the manual mode. That will be better.
Okay, sir. Thank you, sir.
So we will start with the solid state devices. This is the next topic and little bit long topic. Okay. So we will try to analyze this solid state devices when I am going to teach. I think you can see this is a topic. Generally, I tell you about the covalent bond and type of semiconductor, PN diode, biasing, diode limiter, Zener diode, BJT, transistor action, BJT output characteristics, configuration, FET, JFET, D MOSFET, E only MOSFET, IGBT, CMOS, thyristor, SCR like those. Okay. Operational amplifier and everything will go on like this. It will take us at least 1 week. So 1 week I will try to finish this one. So let's start. So I will start with the atomic structure. I will not go so basic, don't worry. It is important to know this atomic structure. So that's why with related to the solid state, we'll be talking only. So if you see the atomic structure, there is a nucleus and around this we have the electrons. Okay, that is the orbiting electrons are there. So this is known as a orbiting cell. Now, this is having a formula as per that these electrons are going to be positioned in their orbiting. As per that, that formula, I think you will be knowing 2n square. Okay, where the n is the cells number. Okay, n is cells number. So first cell that is going to have 2 electrons. Next cell, it is going to have the 8 electrons. If you go as per these formulas, okay, maximum it is going to be the 8. And same way, if we are having the third orbiting cell, so it is going to be 18. Okay, will not go so much. we'll keep up to the 3 cells only. So outermost, we will take only the 4 electrons here. 4 electrons. So these electrons are orbiting in this. Now here, 2 things you should know. One is what is energy level, and second, what is the energy band, because this is related with the solid state devices, semiconductors, it is related. Now, this orbiting cells are there here. So it is having a definite, distance from the nucleus. Okay, it is having the definite distance from here. So we will say like it is having the R1, then it is having the R2. Sorry, and outer one is having the R3. So R1, R2, R3. Now this first orbiting electrons, they are going to have the most binding energy. So here the R1, the cells, near cell, first cells will say, first shell electrons. So they are going to have most binding energy with nucleus. And they are going to have the least energy level. If the energy level we see, if we are going to suppose, we say this is the 0 level here. This is a 0 level. And from here, if we measure the level of each electrons in the cell, then we find, like suppose this is 1 level, this is the 2nd level, and this is the 3rd level. Okay, so this side will be saying this is a energy level. So R1, this is R2, sorry, this is R2 and this is the R3. So first cell electrons, they are going to have the least energy level. Least energy level means it will be the other electrons, it is going to be in the least energy level. Second orbiting one like R2, it is having the next energy, higher energy level. So this side, the level is going to increase. And the outer one is going to be highest energy level. So we'll say the last one, last cell electrons. So last cell electrons like R3 here, as per example, R3. So it is going to have the least binding energy with nucleus, and second, it is having the most energy level or highest energy level. It is going to have the highest energy level. Okay, this is about the energy level. So energy level, the diagram what I have made. So it is as per their orbiting path. So as the orbiting, these shells are going to increase, the energy level is also going to increase, and binding with the nucleus, it is going to decrease. And that is the reason to move out of the orbiting path or this electrons, it is easier with outermost electrons. The outermost electrons easily we can remove from the orbiting path because it is having the least binding with the nucleus, that is the one, and it is having the highest energy level. So if a small energy we give, it will be out, it will be ejected. Okay. So that is the main basic funda of the semiconductors. So we'll see about this one. So this is about the energy level. Now there is a second one that comes about the energy band. Energy band. Again, I am going back to this one. Now, if you see here, we are having the two electrons. One electron is here, one electron is here. These two electrons of the first energy level, these two electrons is going to have the energy, but that will be not equal. Little bit, this will be more and this will be less. But it will be within the a band. It will be within the band. It will be not out of this band. Same way, we have the 8 electrons here. So let me make the band here. So like if the energy level we have seen, similarly, we are going to have the same energy level. We are going to have the electrons, but their energy will differ in that particular level. It will be not the same. So suppose we have the first energy level, that is the R1, we'll say here R1. R1, we are having the 2 electrons. So these 2 electrons are possessing some energy and it will be within this band only. This will be not going out of this band. So this is known as a first band, energy band. First energy band. Okay. Now second one, second band we are going to have here like this. This is the second band. Now here we are going to have the 8 electrons. So these all 8 electrons are going to have a different energy. So this is the second band. But it will be within a band of the energy. Now in between this band, you need to see here, this is known as a forbidden energy level. Forbidden energy gap, we say. Means none of the electron is going to reside in this particular area. Okay, so no electrons will reside in this. And that is the reason their orbiting path, what you are seeing here, there is a gap between this. From nucleus to R1, R1 to R2, R2 to R3. So this is a forbidden area. None of the electron will be in this area. Either they are going to be here or they are going to be here or they are going to be here. So in that particular band only the electrons are going to be there. Now third one, let's see the third. Okay, so here we have the 4 electrons. So 4 electrons are like doing. This is the third band. Third band or outermost orbiting electrons. Okay, that is the third band. So this energy band, this tells us about the electrons, what energy they are possessing and which band in there. And between them, there is a forbidden energy gap. Here also you can see forbidden energy gap. Okay. Now there is one topic I am going to start now. These all are introduction still. There is something is known as a valence electrons. Valence electrons. Valence electrons are the outermost electrons of the outermost band. So in this example, third band is the outermost band. So this band is known as a valence band. And the electrons, these electrons are known as a valence electrons. Okay, so they are known as a valence electrons, and this band is known as a valence band. Valence band. So what is the valence band? Valence band is the electrons in the outermost orbit of an atom are called valence electrons. Now there is a characteristics of these electrons. What all characteristics are there? So first, they have already I have written, but again I am rewriting that. They have the highest energy level. So now this word is coming energy level. Okay, energy level. So now you understand what is energy level. And least binding energy with nucleus. So it is easy to remove them when the additional or external energy is given. Okay, that is the important of this. The energy band occupies occupied by the valence electron. Valence electrons I will write like this. Okay, VE, valence electrons is called valence band. Valence band I will be writing VB. Okay, so try to remember this. Valence electrons, valence band. It may be completely filled or partially filled with electrons, but never be empty. Never be empty. Now, after this, there is next electrons that is known as a conduction electrons. Now, in the energy band, I have told you. Now, suppose there is a energy band. We have the first band here. So, suppose this is the first band. Then there is a second band, and between that forbidden energy gap, there is a third band. And suppose there is a one more band, that is the fourth band. Here. This is third band, we'll write here, valence band. This is the outermost band. Now, after the outermost band, there is a one more band that is known as a conduction band. conduction band. This band, valence band, is having the least binding energy with the nucleus and most energy level. So, if we are going to give some external energy, then the electrons from here will be ejected and it is going to move to this one. When this electrons is going to be ejected, it is going to create a hole. It is going to create a hole. Okay, so these electrons will moving here and it is going to create a hole. We'll see this one later on, but just I am saying you this, and this is how it is happening. And this is going to happen only when the external energy is given. External energy is given. Okay, so the valence electrons, they are going to leave their orbiting path of the valence band and they will move to the conduction band. Now, once it is moving to the conduction band, this electron is known as a free electron. Free electron means now it is not going to orbit around the nucleus. So it is free from that. That's why it is known as a free electron. Okay. Or it is free to move anywhere. Because before that it was orbiting around the nucleus. Now it is not going to orbit. So it is free from that. Free to move anywhere. And these free electrons are required for conduction. For conduction, this is needed. And that's why where these free electrons are residing, that is known as a conduction band. So this is going to be a highest energy level, conduction band. Means after the valence band, this is the again higher level. So this is a conduction band. Okay, this is the permitted higher level. Next higher level, that is the conduction band. So if we see this conduction band, so what we can write about this one, that the next higher permitted energy band is called the conduction band. Conduction band. Okay, I'll be writing CB, conduction band. It may be either empty or partially filled with electrons. Okay, so it is either it is empty or it is partially filled with electrons. In conduction band, okay, CB conduction band, electrons can move freely and hence are known as conduction electron. It is known as a conduction electrons. Now, one more thing I have made here between these, if you see, there is a forbidden energy gap. This is the forbidden energy gap. Now here also we have the forbidden energy gap. This forbidden energy gap, this is fixed between the band. But this forbidden energy gap between the valence band and conduction band is not fixed. So this is not fixed. And it is not fixed. That is the reason it is going to decide. It is going to decide the electrical properties of atom. So this atom, what electrical properties it is having, it is decided by this forbidden energy gap. Means it is a conductor, it is a insulator, or it is a semiconductor. Okay. So this forbidden energy gap is important. So what we can write here, that forbidden energy gap between valence band and conduction band may be very large, very narrow, or overlapping. It may be overlapping. And this decides the electrical properties of atom. So this is going to decide the electrical properties of the atom. Okay. So now we can classify the solids and their energy band. Classification of solids and their energy band So classification of solids, they are going to be either insulator, or they are going to be either conductor, or they are going to be semiconductor. Okay, so the solids, either they are going to be insulator, they are going to be conductor, or they are going to be insulator. So what is the difference between their energy band? So I will be making the energy band here only for all. Okay, now suppose this is the valence band. This is the valence band. Now in the insulator, we have the conduction band. Suppose this is the conduction band and this is the valence band. This is between this, we have the forbidden energy gap. Forbidden energy gap. Forbidden energy gap, generally it is measured in EV, and this is near about 15 eV between these and these. The conduction band may be the empty and this valence band will be full. 1 eV, this is known as a electron volt. This is known as a electron volt and this is equal to 1.602 into 10 to power minus 19 joule. In the conductor, okay, I will make with the some other, this one. So conductor, it is having the overlapping forbidden gap. Like suppose this is a conduction band and here this is the valence band. We'll make it something like this. So there is a overlapping band. So this is a conduction band and here we have the valence band between here and here. So this is overlapping. So from here to here it is having a overlap. Due to the overlapping, the conduction band is having plenty of electrons, or we can say free electrons for conduction. And that's why if we are going to give the potential difference, the electrons will move. It will start freely, it will be moving. So in the conductor, we do not require to give much energy here. Very small energy that it can conduct. The free electrons will be moving. So there is a plenty of the free electrons are available. Now semiconductor is between the insulator and the conductor, and that's why it is known as a semiconductor. So semiconductor, now suppose this is a conduction band here and this is the valence band, and this side we have the energy level. Again EV, here also we have the EV here. So we have the forbidden energy gap between this and this is 1 eV. Generally, the conduction band is it is almost empty, not empty, but it is known as a almost empty. What is the meaning of almost empty? I will tell you what it means. Okay, why we say almost empty, and this is almost filled. Semiconductor status is also depend upon the temperature. In which temperature semiconductor is there? If semiconductor is in the room temperature, then the conduction band is going to have the free electrons. Whereas valence band is going to have the valence electrons plus the hole. Hole will be there in that. But if it is in its zero temperature, absolute zero temperature, then it will act like a insulator. That time there will be no free electrons here and valence band is going to be full. That's why that is the meaning almost empty, almost filled. Okay. So semiconductor at the absolute zero temperature, it will behave like a perfect insulator. Perfect insulator. So here the forbidden energy gap is very, very small. So semiconductor behavior changes as per the temperature. So it is temperature dependent. So temperature, if it is going to be absolute zero temperature, absolute zero, in this case, it is going to behave like a insulator. Whereas if it is in the room temperature, it is room temperature. So at the room temperature, because it is assumed to be gaining some heat, room temperature means temperature has increased, and due to that, the valence electrons will be ejected and it will go to the conduction band. So some of the free electrons are here. And if we are going to give the potential difference in this, then it is going to work like a conductor. It is going to work like a conductor. So conductivity falls between the insulator and conductor. Now temperature I have told, because in the room temperature, it is something like we are giving the external energy. External energy. So if the any type of external energy is given, not only the temperature, if we give the radiation, we give any other types of energy, in that case, the valence electrons will leave and it will go to the conduction band. It will go there. Okay. So in that case, it will behave like a conductor. So that's why it is known as a semiconductor. Semiconductor means when at the absolute zero temperature, they behave like an insulator. And when some energy is given, that time the conduction band is filled with the conduction electrons. They behave like a conductor. Okay, hope it is clear. Any doubt up to here?
No, sir.
Okay, that's it for today. Thank you. Thank
Actually,
you
sir,
very
I
much.
have two questions, sir.
Yeah, tell me.
Sir, first question is how we check our meager it is okay.
Okay, how it is okay.
Yes, sir.
So there is only two things. Like if you are going to short it, then it's supposed to show you the zero value. Okay. When the
Yes, sir.
lead is shorting, it is going to show you the zero value. And when it is open, it is going to show you the maximum value. Infinity.
Okay, sir. That's it, na, sir.
Sorry?
Sir, that's it, na. यही आंसर है ना सिर्फ.
Yes, that is the answer.
Okay, sir. Sir, my second question is if steering gear motor will flood it with seawater,
Yeah.
how you will approach it?
First of all, you have to uh, make it bath with the fresh water. That is the best way.
सर बट इफ आर स्टेयरिंग गियर मतलब जो स्टेयरिंग गियर कंपार्टमेंट वो फुली फ्लडेड हो गया होगा तो उस टाइम पे हम मोटर कैसे निकालेंगे सर?
No. That is not a question. Question is if the motor is flooded with the seawater
हाँ.
and thereafter like water has been removed. Now what you are going to do? What the action you are going to take
ओके
with the
सर. ओके
motor?
ओके
That
ओके
is the question.
ओके ओके.
Okay. So next is you are going to open it, deassemble it,
ओके.
wash it with the fresh water.
हम्म.
Okay. And if you are going to remove the, suppose some grease or oil is there, then better to wash with the your this soda, surf or soda,
Cascade soda, sir.
yeah, whatever it is there with that. So that all everything should be removed.
Okay, sir.
Once it is removed, thereafter you have to dry it up.
Okay.
So drying, after the drying, when you are going to dry it up, try to measure it continuously.
Okay, sir.
It's
Okay.
supposed to improve. If it is improving, that means it is a good sign.
Mm-hmm.
And generally, we keep the motor in the warm places because the steering gear motor is not so big. So we can carry that one, keep at the boiler platform. It is generally hot, or purifier room that is generally hot.
Mm.
Okay, so it will dry up fast.
Okay, sir.
Okay, and you put the lamp.
Yes,
So,
please.
and try to continuously you monitor, and if it is improving, if it is a good sign. If it is not improving, then it is a bad sign. Then we need to send this motor for the rewind.
Okay, sir.
That's it. That is the answer.
Sir, one more question, sir.
Yeah.
Sir, two generators are running in parallel.
Yes.
Sir, kilowatt are same, but current and voltage are not same.
Yes.
Sir, then what we do, sir?
That means your voltage, there is a difference between your set voltage.
Okay.
Okay, set voltage is different. So what action you are going to take is that answer is you switch on without the load first generator. It will happen only in the paralleling, okay, parallel running.
Okay, sir.
So individual you have to start without load and check the reading of the voltage with multimeter, not with the voltmeter that is fitted in the this one, your MSB.
Okay.
Take the multimeter reading and note it down. Okay, that is the voltage reading you need to take. Both the parameters should match. You will find 100% there will be some mismatch will be there with the voltage without load. Okay. Try to make it same. Once you are making it again parallelly, you will find that same reading will be coming of the voltage and current.
Okay.
Okay. If it is not coming, that means your droop setting is wrong. One is having more droop setting, one is having the less droop setting. You
Okay.
need to make same droop setting.
तो सर विद द हेल्प ऑफ एक्साइटर जो एक्साइटर ट्रिमर से हम कर सकते हैं ना सर उसे
Same. That is the trimmer, voltage trimmer that is provided in the MSB generator panel.
ओके सर ओके थैंक यू सर
Okay. Good night to everyone and good weekend.
गुड नाइट सर